Example 34. Without use the calculator, verify that z minus I is a factor and express Fc is a product of all its complex and real factors. Okay, now, to verify that z minus I is a factor, so we get z equals I as a root. So if I sub I into it, okay, I to the power 4 is 1. I to the power of 3 is negative I squared is negative 1. Okay, so you can see we have 1 minus I plus 5 plus I minus 6. 1 plus 5 minus 6, 0. Minus I plus I, 0. Okay, so z minus I is a factor. Now, if z minus I is a factor, z equals I is a root, then z equals minus I is also a root. Okay, because they are conjugate pairs. Okay. The complex number always come in conjugate pairs. So that means the other factor is z plus I. Okay, so z minus I got z equals I, z plus I got z equals I. So if you multiply them, z squared plus 1. So we get the quadratic factor. The quadratic factor is z squared plus 1. So now if I do the division, okay, I can get the quadratic factor. But be careful, z squared plus 1, no term for z. So we must add in 0 times z. Means the coefficient of z is 0. z to 4 divided by z squared is z squared. So this one is just 6. Wait, made a mistake. I forgot. Z cubed minus 0 is z cubed. Yeah. Okay, so this z cubed divided by z squared plus z. But once again, 0z times z is 0. So then you got negative z squared plus 0z minus 6. That's why the last one, negative 6z squared divided by z squared is negative 6. Okay, so z squared plus z minus 6, if I factorize, z plus 2, z minus 3. That's why the 4 factors are z minus I, z plus I, and then the 2 real factor, z minus 2, z plus 3. Okay, so when you watch the video, please take note. Here I made a mistake. This is the correct working for the long division. Okay, last example. Okay, here they mention about remainder, so we need to use the remainder theory to do this one. Z plus 2 equal to 0, Z minus 2. When it's divided by Z minus Z plus 2, there's a remainder. Means if I sub negative 2 into it, oops. Okay, this one should be equal to 135. Now that is remainder theory, okay? Z plus 2 equal to 0, Z is negative 2. You divide it by Z plus 2, you get the remainder 135. Means if I sub negative 2 into the function, the Y value should be 135. From here, we'll get an equation of A and B. Okay. First equation. Second equation, one of the factor is 2Z minus 1. So if the factor is 2Z minus 1, you sub Z equals half, you should get 0. This is the factor theory. Okay, so here I should get half. This is A, So 1 over 4A plus 1 over 2B equal to 3. Second equation. Okay. The second equation, right? If I times 4 times 4. Okay, so 1 over 4A times 4 is A. 1 over 2B times 4 is 2B. 3 times 4 is 12. Okay, equation 1 plus equation 3. 5A equals minus 10. So A is negative 2. Okay, minus 2B plus 2B cancel out. Then the B minus 2 plus 2B is 12. 2B is 10. B is 5. So A should be negative 2. B is 7. Make mistake here. I think I'm too tired. 12. So this is 12 plus 2. So it's 14. 2B is 14. So B is 7. Okay? Yeah. So A is negative 2, B equals 7. Okay, so we use the remainder theory. We use the factor theory to get two equations and with two unknowns. So we got A is negative 2, B equals 7. Okay, now continue. So now our function is then, this is a very long one. A Z to 4, or Z to 3. A is negative 2, so it's minus 2Z squared. B is 7 plus 7Z minus 3. Okay, and we also have two factors. They are 2Z minus 1 and Z plus 2. Okay. 2Z minus 1. The other, No, sorry, only have one factor, 2z minus 1. Z plus 2 is not a factor. If that's the case, okay, so we just do the long division. Okay. 0 divided by 2z, okay, it's a 0. Negative 2z squared divided by 2z minus z. 7z minus z, 6z. Okay. Yeah. So the function of z is now 2z minus 1, 4z cubed minus z plus 3. Now for this one, we have to do try and error. Okay, for example, if I try z is 1, 4 minus 1 plus 3 won't be 0. If z is negative 1, negative 4 plus 1 plus 3, that is negative 4 plus 4. So this is 0. This is a root. Z plus 1 is a factor. Okay. In order to keep the format of polynomial when there's no z squared, we still need to write 0 times z squared. Okay. So now we do another round of long division, 4z cubed divided by z, 4z squared. 0z squared minus 4z squared, negative 4z squared. Negative 4z squared divided by z, negative 4z. Negative z minus negative 4z, 3z. Okay, so we have 2z minus 1, z plus 1, 4z squared minus 4z plus 3. Okay, in fact, when you just quickly look at the value of a, b, and c, you should know this one is bound to be complex roots, okay? Because b squared minus 4ac is less than 0. So minus b plus minus b squared minus 4 times a times c over 2a. (16) minus 6 times 6 is 16, 48. Minus 32. So it is 4 plus minus. Okay, now it's root 32 times root negative 1. And then, okay, this is 4 minus plus. Okay, root 32 is root 16 times root 2. And then root 16 is 4. That's why it is 4 plus minus 4 root 2 times I over 8. One over 2 plus minus root 2 over 2i. So that's the remaining two roots. Once again, conjugate pairs. That's how you get all the four roots. Half minus 1, half plus minus root 2 over 2i. Okay, so this question is very long, so I just quickly recap with you. Now, initially, we sub z equals half. P half is equal to 0. This one is the factor theory. Okay, and then we also sub z equals -2 get 135 because 135 is a remainder. So here we use remainder theorem. We get the two equations of A and B. We find A and B. Okay. Now we know that 2z minus 1 is one of the factors. So we do the first round of long division to get the cubic function. For the cubic function, we have to guess a root, and we guess z equals -1. It happened to be the root. So z equals -1 is the root, then z plus 1 is the factor. So we do another round of long division. Then we get the quadratic equation. Now this one you can try, but you realize cannot factorize. So we use quadratic formula. And then we find out the b squared minus 4ac less than 0. Therefore, it's bound to be complex. And then we find the other two roots. So that's how you get z equals -half. So z equals +half. Z equals -1. And then z equals half plus minus √2/2i.